Everyone, this is a video about a tool on cloud gaming performance measurement. The cloud gaming is that instead of the traditional logic which you render all these game frames on your local machine with a powerful GPU, you do this work on a remote server, and this remote server will send the video streams back to you. So like you could play it on a cheaper machine, for example, like a mobile phone or like a cheaper PC. And the problem with this approach is that the video size is actually much bigger than the game data size. A video is usually like several megabits per second at minimum, while a game data may just be like someone is moving 10 steps forward. This could be captured in like 10 bytes or something. And if in the network some packets of the video data is lost, then like the frames could not be rendered, and like the video would just be lagging there and you could not play the games anymore. In order to study how it really performed, we use this like technique like showed in this Reddit post, that like if you just press Command N, NVidia Geforce, which is a cloud gaming platform, actually shows this like data board for you. What I did was just like I wrote a JavaScript that could be putting a developer console, and this will scrape the HTML that generates the data board every second. And for example, these data are like the ping data, which is the delay of the frame, the frames lost per second, the packets lost per second, which is like the frames or the packets is supposed to be sent to you, but however it just gets lost in the while, and then the total bandwidth that your computer is having and the real bandwidth used in this gaming session. I measured it in John Crawl Library 34 with Wi-Fi, EDU-ROM, and I was using a MacBook Pro 2016 version playing CSGO. So here are some like rough results. This may be a little bit overwhelming. We'll get to like these three later on, but this is just to give a rough sense of which data are provided or captured in this set. Over a 150 second time span, you can see the bandwidth is flowing and there are a lot of packet loss happening. And like these packet loss usually just like correlates directly with a frame delay increase, and in terms of like experience, it's just like you suddenly feel like you can't move anymore for like roughly like half a second, and then like it goes fine on afterwards. And an interesting discovery is that like, if you look close into the data, at first it's the increase in the used bandwidth. In this case, it's like around 42 to 43 seconds, and then the packets get lost around like 44 seconds. And this could be caused by, say, like the router receives too much packet and it has to drop some of the packets because it can't hold all of them in the buffer anymore, and then like because the packets are lost, the receiver does not know like which frames to render, like, and this like actually causes the per frame delay to increase later on. This is this is a rough problem, and so if you follow this pipeline, you will see that the root cause of damaged experience is that the bandwidth suddenly increases. And here is a comparison between a low bandwidth, a low bitrate video and a high bitrate video. On the left is a very low bitrate video, and like on the right is a high bandwidth video. The left is like a guy using a sniper, and the sniper is moving very slowly with more than half the screen just being black all the time, so it's not changing and you don't have to send anything to capture it. On the right is like the guy is moving rapidly and all the screen is changing, which results in like the right screen has like 3 times more bitrate than the left screen. To conclude this video, is like packet loss is prevalent in cloud gaming, and it could be caused by a sudden increased video bitrate, and like video complexity may be a cause of this, and this could be potentially be like like this could be improved by just like predicting the video complexity, and then like do some loss protection before sending it out if like the video gets like more complex. Here's the GitHub link, and hope you enjoyed this video, and thank you for listening.